Let's delve into a more complex example involving the extraction and analysis of specific file attributes, including timestamps, from a disk image using the pytsk3 library. This code will not only list files but also recover and display essential metadata for further forensic analysis. This code will print the names, inode numbers, file types, sizes, and timestamps, access, modification, and creation of all files in the specified disk image, including those in subdirectories. Breaking it down, line by line, we see we're using the pytsk3 library to interact with disk images and the datetime module to handle timestamps. We open a disk image file to analyze its file system, enabling us to interact with files, directories, and other file system structures. A timestamp conversion. Convert_timestamp converts Unix timestamps to human-readable dates and times. This is critical for understanding when a file was accessed, modified, or created, as timestamps can reveal patterns of activity. We then move to the file analysis function. Analyze_file extracts and prints various attributes such as the file name, inode number, file type, size, and timestamps. These details can be instrumental in forensic analysis, providing insights into file ownership, changes, access patterns, and potential evidence of malicious activity. Next, its directory iteration function. Directory_iterator recursively traverses directories, applying the analysis function to each file, revealing a complete view of the disk image. In the execution, we start the analysis from the root directory, calling our defined functions and printing the results. You want to know how to expand? You can recover deleted files. We could modify the code to recover and analyze deleted files, providing a view into previously erased data and potentially revealing hidden or malicious activities. You can export to a report. Rather than printing results to the console, we could write the data to a structured report, like a CSV file, facilitating further analysis with other tools. Integrate with other libraries. Combining pytsk3 with other libraries like pandas for data analysis or matplotlib for visualization, it would allow us to create more complex analyses and visualizations of the data. Analyze specific file types. By focusing on particular file types or extensions, we could perform specialized analyses, such as extracting metadata from images or content from documents, revealing more detailed insights. Automate the detection of suspicious patterns. Implementing machine learning or heuristic-based analysis, we could detect suspicious or anomalous patterns in file access or modifications, providing automated alerts for potential security incidents. This example illustrates the power and flexibility of digital forensic tools in Python. By understanding the underlying code and its potential, cybersecurity professionals can tailor their analyses to specific investigative needs, uncover hidden insights, and contribute to the ongoing defense of digital assets. Stay tuned for the next video, and remember to like and subscribe for next video in the ethical hacking series.